Thank you very much for inviting me for this talk today. And the title of the talk is From Farm to Fork, and I'm Andrea Rossi and I work at the Italian Metrological Institute. And the outline of the talk, I would like to touch the following point. One is related to metrological impact and metrological needs related to the food metrology. And the other point are the application of the measurements to the food origin determination. And the last part, some slide dedicated to the application of nanotechnology to and in combination with vibrational spectroscopy to increase the sensitivity of the method. It's well known that the food usually starts from the farm, and after chemical modification and processing arrive on the table of the consumer. Along this chain and also on the distribution is necessary continuous measurements to guarantee the origin, the quality of the food. And in particularly in a worldwide market, it is necessary to control the food with a lot of sampling and a lot of measurements. Therefore, the metrology should address the precise, reliable, traceable measurements, and if possible also to develop new methods of measurements. One aspect clear is that the certified reference material is one product of metrology research that is necessary to standardize the metrics where we are working on. And in particular, the food metrology need to address the food composition to guarantee the composition, the amount of also of the substance inside following the labeling. And another aspect is the food provenance, because there is a big market clearly related to the food where it comes from, and clear with the global market add value if some food is produced from one country as opposed to the other one. And another aspect is important to contaminants in the food that was measured and need to fastest and more precise and reliable measurements on the contaminants inside the food. Therefore, the food traceability impact clear in our society, and in particular the consumer demands continuously labeling and transparency, because we want to know what we are eating. Another example is also on the claim of the organics, because there is add value about this type of food, and therefore it's necessary to guarantee the organic claim. And the other aspect is some food traceability, for example, related to the mad cow disease, to check where the meat comes from in this case, and also to follow the genetically modified organism, because the debate is about if the illness or not about that. Anyway, for the food traceability, impacted the food safety incidents, in particular the food residue surveillance program that the Institute designated to do this job. Moreover, to also evaluate the risk assessment from food exposure and enforce the labeling claims and to prevent the fraud. Clear that we need to measure and to control not only the food that arrive on the table, but also the food provided to feed the animal, because clear that, for example, in the case of mad cow disease, was the use of the bone fiber of animal cannibalism was the problem related, and therefore impact of directly of the health of the human being. I would like now to dedicate the next slide in part with my migration of my patient related to vibrational spectroscopy and to this application related to the food analysis. The idea is to apply a technique that allows to obtain a fingerprint of the substance. Each substance has in particular fingerprint in the graph show the spectra of the Raman about in this case was hazelnut, and this technique allowed to do the measurement without usually any particular treatment of the sample and without any counter of the sample. And therefore this technique is also allowed to do several sampling, because the sampling is a very big problem related to the measurements world, meaning that we need more measurements, but we need also faster method respect probably for the standard method proposed. And another point is that not always is necessary to quantify or identify the material, but sometimes it's also to understand the change respect of the standard. And in other hand, if we have a standard kind of substance and there is any variation of the standard, so we are confident that something is going wrong. It could be a fraud or it could be some contaminants presence. The vibrational spectroscopy look at the vibration of the bond, in particular in the infrared they look at the variation of the moment of the dipole and therefore the variation of the center of the mass. While on the Raman spectroscopy we are looking the variation of the polarizability of the molecules. And about the vibrational technique, there are three main techniques that two are near infrared spectroscopy and medium infrared spectroscopy that allow in food chain to analyze, for example, the bacterial contamination in the meat, the amount of protein and the moisture and total fat. While Raman spectroscopy is used, but in those cases more used because it's technique more cost effective. The instrumentation is improved the performance. Is it possible to analyze the material and to determine, for example, the food provenience. The advantage of these techniques with respect to other techniques is it possible to analyze directly through the container, for example, a bottle, and the water is not a problem for Raman spectroscopy. Now I would like to briefly show you some research that we in INRIM did. One is related, for example, the analysis of cheese. We directly analyzed two different types of cheese without any sample treatment. The cheese was produced in two different areas. One was in Piedmont and one was in the Veneto place. And the same cow grazed on the pasture and in the different period of the year where the food, when the pasture change the variability. Therefore, in one part of the year there was a trefoglio repens, and in the other part of the year also was a festuca. But what I would like to show you that the Raman spectroscopy was allowed directly to determine the period of the year, and therefore also the type of the grass directly analyzed the cheese was produced. In the blue line there is the festuceto in the period of the year where the festuceto was grown, and the other one, the pink one, related to the foliatus period of the year was present. In both of the cases it was possible to analyze using, in this case, the mathematical model, the monadonic distance, to determine the difference in the two periods of the year. Change the metrics, and then we move to a liquid one, and we did some experiment related to the wine. The wine in our region is very important, also in our nation, for the export, and therefore to prevent the fraud is one important aspect. In In this case, we applied for the first part to identify the type of the grape. In this case, 3 grapes of Piedmont region, while the Nebbiolo, Barbera, and Roche was analyzed, and Raman spectroscopy, this is the one of the distance that showed the spectra, was able to distinguish the spectra, the black, red, blue one, the type of grape making the wine. We did a following step to try to, for the same grape, identify the different type of wine. In this case, we are speaking about the wine that the cost of the bottle ranging from 20 up to 100 euros bottles, and export worldwide. Therefore, is important in this case to prevent the fraud related to other wine from other region or country. Anyway, the techniques was able to distinguish. Keep in mind that it's the same grape. The only things that change the name is Barolo, Baresco, or Carema, or Gemen Cattinara, that the different place where they are produced. This is Barolo, this is Carema, and this is Gemen Cattinara, and the difference is related to this wine. Respect Nebbiolo is the aging time that is around 4 and 5 years. Therefore, the technique was able to distinguish the food, in this case, one provenience of the wine respect to the different region. Now I will relate it to the application and part of nanotechnology. INRIM is a project leader of FP7 program and in collaboration with the University of Turin related to the standardization of titanium dioxide nanoparticle. The project is related to the production of titanium nanoparticle with the finer shape and size, and moreover to measure the structural, morphological properties, because it is important in this type of material with different crystallographic shape, also that the application and the interaction with the environment change respect of the surface termination and dimension of nanoparticle. This project impact in the electric environment and in health. I would like to just to remind what is the correlation also the titanium dioxide in the food goods that is possible to find in this graph. Show you the 20 products where the titanium dioxide are different type of candy, coffee cream, vanilla gum, cake or whatever, present in the food. And in the other graph I show you the range of the nanoparticle shape from 40 to 200 nanometers. The important point is that a recent study demonstrated that the possibility of toxicology and the carcinogenic properties of these particles were in some states. Therefore, it is important to have such kind of standard to get a metrological information about of these particles to determine the degree of their toxicity. The nanoparticle should be not only a problem, but clearly it's also an advantage in these days. Because it is possible to use the nanoparticle to increase the sensitivity of the method. In this case, this is the nanoparticle produced in our laboratory of different dimension corresponds, in this case, a different color. The ranging was about 20 nanometers up to 100 nanometers. In combining the nanoparticles with the Raman spectroscopy, it is possible to obtain a technique called the surface enhanced Raman scattering, where we are using that plasmonic effect in the nanoparticle, and this method allows to enhance the factor up to 10 to 10, 10 to 11, the sensitivity of the method. We apply this method to evaluate evaluate the melamine in the milk. The melamine in the milk was a problem particularly years ago because it was fraudulently added in the infant formula milk to boost the amount of protein. But the problem with this chemical reaction with cyanuric acid and provoke a kidney failure in children in China. 100 people died for this problem. Therefore, we developed we developed a method colorimetric and using surface and enhanced Raman spectroscopy technique. In this case, in the cuvette is present the water, and the other cuvette there is a 0.1 ppm of melamine and 1 ppm of melamine. The reaction is shown on the left side. The nanoparticles are binding from with the melamine, and the melamine forms two aggregates. The dimension of aggregates here depends on the amount of melamine, and the reason of the color change that depends of the amount of melamine in the solution. Here it is possible to increase the sensitivity. In this case, our naked eye is not possible. We need, in this case, the spectroscopic technique to analyze the small change in the color spectra. And we combine also this method in milk using surface enhanced Raman spectroscopy. In this case, the nanoparticle bind with the same effect that we showed previously. But as you can see, in this case of the melamine, with 1000 of ppm of melamine that doesn't show any Raman spectra, while adding a nanoparticle 2.5 ppm of melamine show the strong spectra. And this allows us to obtain good results about the surface enhanced Raman spectroscopy to determine the melamine in the milk. All this work that we did was impossible here without the collaboration, and we have other colleagues working in this field. Thank you for your attention.